Now, as normal, once we have this idea of area models, we can now generalize it to different and larger numbers, which is what we're going to do now with multiply 3 and 4 digits by 1 digit with area models. So now we have this number here, 119, again broken into parts, broken into its hundreds, plus its tens, plus its ones. And again, we're going to do the exact same process of finding the areas of each of these rectangles and then adding them together to make one single sum. So it looks to me like 5 times 100 is 500, 5 times 10 is 50, and then 5 times 9 is 45. So what I get is 595. Up next, we have 5 times 1,000, which is 5,000. 5 times 800 is 4,000. Remember, it's just 5 times 8, which is 40, and then add the extra 2 zeros. And then let's see, 60 times 5, well, that's 3,000. That's 300, not 3,000. And then 3 times 5 is 15. So it looks to me like we get 9,315. Up next, here we have 483 times 6. 6 times 400 is 2,400. 6 times 80 is, I believe, 480. Yeah, because 8 times 3 is 24, times 2 is 48, yes. So 480, and then 6 times 3 is 18, and then just add them all up. 2898, it looks like. Did I do that right? That's 2880, 2898, yes. And finally, 5 times 3,000 is 15,000. 5 times 500 is 2,500. The idea of this is if you have your times tables down, which again, the times tables are not a necessary part of math, but they do help. If you've got them down, then you've got this down, right? This is just basic times tables. Throw some zeros in there, and then there's some addition. The addition is probably the most mathematically demanding part of this process. 5 times 30 is 150. And then 5 times 8 is 40. Okay, so we get 17,500, 17,650, 17,690. Boom, done and done. So that is using area models to multiply numbers together. Now, as you've probably guessed, we are going to expand this pattern further and further, and eventually you can use it to, multiply any two numbers you want. Although obviously, the larger the numbers get, the more impractical this becomes and the more necessary calculators become.